So hello everyone, in this video we'll be working on numbers. So let's understand what are numbers data type and how can we actually work with numbers and what kind of operations we can perform on numbers. So JavaScript supports both integer and floating point numbers that can be represented in decimal, hexadecimal or octal notation. Unlike other languages, JavaScript does not treat integer and floating point numbers differently. If you go to other languages such as Java or in other languages, we have to specify the data type for that variable. For example, if you're storing integer in a variable, then you have to specify int in the starting. But in JavaScript, it isn't the case. We don't have to specify the data type. It is automatically taken care by JavaScript. So we just specify var val and then we specify the variable name, and after that we can assign numbers, integer or any kind of data type to the variable. All numbers in JavaScript are represented as floating point numbers. Here's an example demonstrating the numbers in different formats. So you can see the first format is the integer format and the other format is the 3.11 or 3.14. This one is a floating point number. When you see this decimal, always remember that this is a floating point number. And then we have this hexadecimal number which has this hexadecimal code. So you can represent numbers in different formats in JavaScript. So what can we do numbers and strings with? So what can we do with both of them? As you know from the previous chapters, the plus operator is used for both addition and concatenation. So if we use a string, so we can concatenate two strings with this plus symbol. And if we use plus with the numbers, if both the variables or the operands are numbers, then it will actually add both of them. Otherwise, it will concatenate them. So performing mathematical operations on numbers and strings may produce interesting results. So you can see what we'll be doing. You can see we have this variable x. Inside that we have stored 10, and then we also have this y variable in which we have stored 20 as a number. You can see there is no string here. And then we have a z variable which has 30 as a string stored inside. Now if we add x plus y, which both are numbers, so it will result in the addition. You can see 30 is returned. So 10 plus 20 is 30. But if we add two strings, let's say z and z, so you know from the previous chapters that when we concatenate, when we add plus symbol between two strings, so they are concatenated. So that's why we can see 30 30. So this is the concatenation or joined result of both the variables z and z. Adding a number with a string. So if we add a number with a string, so still it will concatenate the number, not add it. So you can see 10 is a number and z is 30 as a string. But if we concatenate them, so it will return us a string which is the concatenated string 30 10 30. So you can see 10 is a number, was a number, and 30 was a string. Now it is concatenated as a string 1030. It will not add the numbers if one of them is string. We can also do this oppositely, like we can add z first and then after that we can add x. So the result will not change, it will still concatenate the numbers, but oppositely. Adding strings and numbers, the result will be string concatenation. You can see if we this double quote is a string. I know both of them are number, but if we are adding it with string, so at that time it will actually treat other numbers as strings. So it will concatenate them, not add them. So remember, when you are adding both the numbers, you don't have to add it with the string. You can do it separately if you want to actually add the numbers. Otherwise it will concatenate the number or join the number instead of adding them. Now similarly we have this one. So we have x plus y plus z. Now you can see x plus y is actually added and z was 30. So the result of x plus y was 30, and then 30 plus 30 is concatenated. So we can see the result is 30 30, which is a concatenated result. So this is the case. So I have already explained you. So this thing you can remember, JavaScript will automatically convert numeric strings. It implies strings containing numeric values to numbers in all numeric operations as shown in the following example. So you can see if we actually like subtract the number, so it will automatically convert this string as a number. So earlier it was converting or concatenating the numbers without changing their data type, but in this case it will change the data type of this string into number, and then it will give us the minus result or the subtracted result. You can see we have these three variables. Now if we uh, like subtract y minus x, means 20 minus 10, so it will result 10 because both the numbers are number. And if we do z minus x, so still it is giving us the right result. You can see it is doing the subtraction, 30 minus 20, so it is giving us 30 minus 10, it is giving us 20. So that is the case. So if you subtract the number, so it will automatically convert this string into number, and then it will do the operation of subtraction. Similarly we have this one, multiplication. If we multiply a number with a string, so it will actually multiply it by converting the numbers, like the string data type, into number. Now you can see 30 multiplied 10, 300. So it actually multiplied this 30 by 10 by converting this 30 to number format. That's why it is giving us the right result. We also have z divided by x, so you can see the right result is there. So only in the addition we get the concatenated result, and we don't change the data type of the string variable if we have string and we have stored number. But in the other operations you can see it is actually automatically converting the string into number and then performing the operation. So this is the case. Moreover, if you try to multiply or divide numbers with strings that are not numeric, it returns not a number. Also, if you use nan in mathematical operation, the result will also be nan. So if you, in this case, 30 is a number, right? But is a string. It is actually a number, but enclosed with a string. So it is treated as number. It can convert into number. But if let's say if I write Ram here as a string, and if I try to multiply it with 10 or a number, then it will give me the not a number result or nan result. And if we multiply anything with nan, so it will be nan itself. So you can see we have this foo, which is a word and which cannot be converted into number. You can see that. But if we multiply that, you can see y minus x is returning us not a number, because we cannot convert this foo into a number. If it was a number, like if it is just a, like, let's say if it is 30 in double quotes, then it can convert that 30 from string to number, and then it can perform the operation. But in this case it cannot convert this foo because it is a word, it is not a number. So this is the case. You can see all of them are returning us the wrong result. You can see we also have the infinity result, which comes when we divide something with 0, or any operation which gives us infinity as a result. So at that time we'll get this infinity. You can see I'm dividing 5 by 0, so in this case we get the infinity stored in this x variable, and we are console logging that. So infinity represents a number too big for JavaScript to handle. So when there is a number which is very long, so it will result you the infinity. JavaScript has a special keyword infinity and minus infinity to represent positive and negative infinity respectively. So in this case you can see minus infinity is there because minus 5 was divided by 0. And for example, dividing by 0 returns infinity as demonstrated. You can see that. We also have this precision problem. Sometimes operations on floating point numbers produce unexpected results as shown here. So if let's say if I add both these numbers, both these floating numbers, 0.1 plus 0.2, then it will not give me the 0.3 as a result. Instead, it will give me this result. You can see 0.3000 and then till the last precision. So as you can see, the result is this one rather than the expected 0.3. This difference is called a representation error or round off error. It occurs because JavaScript and many other languages uses binary base 2 form to represent decimal base 10 numbers internally. Unfortunately, most decimal fractions can't be represented exactly in binary form, so small differences occur. So that's why we get this result, because it uses binary format to convert all the floating point numbers. That's why we get sometimes this precision problem, but we can solve it easily. To avoid this problem, you can use the solution something like this. You can see in this, if you use, if you add it and if you divide it by 10, then it will give you the right result. You can see here. So 0.1 multiply by 10 plus 0.2 multiply by 10, and then we are adding both of them and we are dividing by 10. So actually first we multiplied them and then we divided them, so no result. It is just like this same as 0.1 plus 0.2. Instead we just multiplied them by 10 to remove that precision error, and then here also, and then we add the last divided by 10, so no change happened in the equation. So everything works fine now and we get the right result. JavaScript round uh, floating point numbers to 17 digits, which is enough precision or accuracy in most cases. So we can also perform some operations just like string. On the string we can perform some operations like we had the methods and properties just like length, slice and others. Similarly, we also have some methods on numbers. Let's see, which we can access by using dot notation. We have this parse int method which can be used to get the numerical result from a string. This method is handy in situation when you are dealing with the values like CSS units. For example, if you want 50 from the 50 pixel or 12 from 12 pt, etc., just like that, and you want the numerical value, not the string. So at that time you will use parse int method, and then we can convert this 50 pixel into 50. So then this method will automatically grab this 50 number. If the parseInt method encounters a character that is not numeric in the specified base, it stops parsing and returns the integer value passed up to that point. If the first character cannot be converted into a number, the method will return not a number. So it will result not a number if we are parsing a string which is not a number. Make sure you add the numbers at the starting, otherwise it will not give you the right result. You can see in this case parse int, we have specified a string 3.14 and it is returning us the integer value which is 3. In this case also, if we are parsing a 50 pixel string value, so it is returning us 50. Same goes for 12 pt and this one. And we can also specify that this is a hexadecimal code, so we can get the result in hexadecimal format as well. So these were the decimal format which is the default result. Similarly, we have this 20 years, we can get the 20, but it will not go after the first letter. So if the first letters are not number, so it will not go to the last numbers or in between the numbers, it will give you the not a number result. Similarly, we have this 10, 12, and 2018. So we get the 10 result as an integer. So this parse int is a very useful function you can use. Similarly, we have parse float. If you want to get the floating point result, so at that time you will be using parse float. So it is just like parse int, but parse int only gets the integer part of or integer value from the string, but the parse float also gets the floating point or decimal numbers as well. So you can see 3.14 in earlier case it was only 3, but now it is also grabbing 3.14 as well. And 50 is also 50. 1.6 is 1.6, but if I had used this parse end, so it will give me 1 only, not this 0.6, because integers doesn't treat floating point numbers or decimal points. We also have this toString method, which can be used to convert number to its string equivalent, or we can convert numbers to string. So now you can see 10 is a variable, 10 is a number stored in this x variable, and then we can use toString method to convert this 10 into a string. So you can see the result will be this double quote or the single quote 10. And if we check the type of y variable, then we will get the string result because we have converted this 10 into string. And if we check the result, or if we check the type of this x variable, which is a number, so it will give me the number. Similarly, we can convert 12, any number, we can convert that to a string. And we can also convert that to hexadecimal string by adding 16 in the brackets. We can also convert that to binary string by using 2 in the brackets. So we can convert any number to binary by using toString, and in the brackets we can specify 2 here. By default it will convert to decimal equivalent or decimal string numbers, and if you want to specify that in binary, so you can specify 2 here, or if you want to specify that in hexadecimal, you can specify 16 here. We also have this toFixed method. This is used when you want to format a number with a fixed number of digits to the right of the decimal point. So if you want to have only fixed digits at after the decimals, the value written by this method is a string, and it has exactly specified number of digits after the decimal point. So it specify how many number of digits you want after the decimal point. If the digits parameter is not specified or omitted, it is treated as 0. So if it is not specified, so it will not get that. It will treat it as 0. You can see 72.635, we have this number, which is a floating point number. And if I use x dot, x is a variable. If I use x dot toFixed, and if I don't specify any number here in the bracket, so it will add 73. It will give me the 73 number because it is rounding this number, and then it is giving us the result. But if we specify toFixed and we specify the digits, number of digits after the decimal point, so it will actually do this 664. Why is that? Because it is rounding off, rounding this number actually. So 63 was the result, but it increased that 3 to 4 because the next digit is nearer to 10. That's why. So it increased that by 1, and then it gave us the 64 result. Similarly, we have this if I specify one digit, then it will give me 72.6 as a result. Similarly, we can use it on these kind of numbers, which are exponential numbers or scientific form of writing exponential numbers. Similarly, we have this, and we can also use them. So this was the end of the slide, and we did all the methods in this. We described all the methods. I hope you got something. Thank you for watching. Let's meet in the another one.